Hi guys, today we are going to continue the kinematics chapter as part 2, and in this we are going to discuss some MCQs and the basic numericals regarding kinematics. So you can see here an example that of a cyclist who has traveled 6 km due east and then makes a turn to travel a further distance of 8 km due north. The whole journey takes 2 hours, and we have to calculate here first of all the distance traveled by the cyclist. So we know that to find the total distance we always have to add the distance which are given to us. For example, here in the first hour he has covered a distance of 8 km and then further 8 km due north. First 6 km due east and then 8 km due north. The whole journey takes 2 hours. We know that to find the total distance, simply we add the distance given to us. So we will add 6 km and 8 km. This will give us 14 km. So the total distance covered is 14 km. Then in the next part we have to find the average speed of the cyclist. For that we will divide the total distance by time taken. We know that average speed is given as total distance covered divided by total time taken. So total distance covered is 14 km and total time is given to us 2 hours. So dividing 14 by 2 we will get 7, and the average speed of the cyclist is 7 km per hour. Now we have to find the displacement of the cyclist, as it is given that in the first hour the cyclist moved 6 km due east and then 8 km due north. For that you have to use Pythagoras theorem, and then solving it by Pythagoras theorem we have to draw the lines in the respective direction. So first of all, as it is given in the question, 6 km due east. So let's suppose that this is 6 km due east, and you can also do it by vector addition method. So for 6 km due east you have to draw 6 centimeter line in such a way that 1 km is represented by 1 centimeter line. And then after that the cyclist further continued 8 km due north. So for north you have to continue it from this point where it ends in the first hour journey to the north direction for the second hour. So the starting point of the cyclist was point A, from where he has started his motion, and then from A to B, this is the distance covered by the cyclist due east. So for the frame of reference we know that if we are going to cover the distance in this way, so that will be simply okay. So when you want to find the displacement from A to C, so it means that for this you have to join the point A with point C. This will give you the displacement from A to C. So you can verify it by vector diagram, vector addition method, or you can also use Pythagoras theorem for finding the total displacement. So you can see that the distance covered from point A to C is actually giving the displacement of the total journey. if it is 6 kilometer due east and this is 8 kilometer due north, because the frame of reference, for the frame of reference, remember that we have to show the east, west and north, south. So on the right it's east, on the left it is west, on the top it is north, and at the bottom it's south. According to the given question, the cyclist first traveled 6 km due east. So you can see that I have drawn the first line from A to B of 6 centimeter with the chosen selected scale as 1 kilometer is equals to 1 centimeter. So for 6 kilometer journey I had drawn, let's suppose, a 6 centimeter line, and then from this point the cyclist further continued his journey 8 kilometer towards north. So for north we know that we have to move in the top direction, in the upward direction. That's why I just, you can consider it that it's a 8 centimeter line that is representing 8 kilometer distance, whereas a 6 centimeter line is representing a distance of 6 kilometer. Now you are going to measure this displacement by scale diagram. You can do that, and as well as by following the Pythagoras theorem, that is hypotenuse square is equals to base square plus perpendicular square. This is Pythagoras theorem, and this we can only use in right angle triangle case. So according to Pythagoras theorem, hypotenuse square is equals to base square plus perpendicular square. So in this way you can find the displacement of the journey traveled by the cyclist. Okay, now as we know that the base is of 6 kilometer, so taking the square of 6, and then the perpendicular height is 8 kilometer, that is the journey done in the second hour. So you have to take the square of base value, that is 6 square, giving you 36, and the square of 8 as 64. So adding these two you will get 100. This is hypotenuse square, but we have to find the hypotenuse length, and its hypotenuse square. So when we are going to remove this square, then its value will come under radical sign. So in this way we got here hypotenuse as under root 100, that is the square root of 100, and that is 10. So from here the displacement we got is 10 kilometer. So remember that whenever we are going to find the displacement, and if it is not in linear straight direction, if it is for the first time it's given in one direction, and then from that in the next journey either the body is moving above that point or below that point, indicating towards north or south respectively, then we have to draw its diagram that give us a sense how to calculate the displacement. So from the given condition I just drew a 6 centimeter line representing 6 kilometer due east, and then from that point in the next journey of 1 hour the cyclist cover further 8 kilometer due north. So I have drawn 8 centimeter line representing 8 kilometer towards north. So as I told you, for the vector diagram we know that we have to choose a suitable scale for it. So as I told you that I have selected the scale here as 1 centimeter is representing 1 kilometer. distance. This is the scale that I have selected here. Then using the Pythagoras theorem, you can see here that it's a right angle triangle case, and if you are going to find out this hypotenuse, you have to use the Pythagoras theorem in this for this right angle triangle. According to Pythagoras theorem, hypotenuse square is equals to the sum of the squares of the other two sides, that is base square plus perpendicular square. Substituting the value for base and perpendicular, then we took the square of these values and adding them together, finally we got hypotenuse square as 100. Now we have to find here hypotenuse, that is, for this we have to take the square root on both sides. That will give us hypotenuse is equals to under root 100. So when you remove a square over hypotenuse, then the answer that is given here for hypotenuse square 100, that this value will come under radical sign. So square root of 100 is 10. So the hypotenuse, this is representing the displacement of 10 kilometer. So what does here the displacement represent? The hypotenuse represent us displacement. So we got the value for displacement as 10 kilometer. Now to find the average velocity, we have to divide the total displacement by total time taken. Total displacement divided by total time taken. So total displacement we got here as 10 kilometer, and the total time of the journey we know that it's 2 hours. So dividing this 10 by 2, we got the average velocity as 5 kilometer per hour. 5 kilometer per hour in the northeast direction. 5 kilometer per hour in the northeast direction. So this line, which is the hypotenuse line, is giving us the direction of displacement. So whatever be the direction of displacement, the same will be for velocity. And because this line is drawn within north and east, so that's why I'm saying that the average velocity is 5 kilometer per hour northeast, that is in between north and east. Okay, now for so after solving this, we are going for the next part. In this example, a boy runs 5 kilometer due west and return back to travel a further distance of 4 kilometer before resting. So in the first condition, the boy covered a 5 kilometer distance due west, that is towards west, and then from that point he returned back towards his starting point 4 kilometer. So what will be the distance traveled? Simply adding these two values, that is 5 kilometer and 4 kilometer, that will give you 9 kilometer. So the total distance traveled by the boy is 9 kilometer. Then for average speed, because the total distance is 9 kilometer and the total time of the whole journey is 1 hour. So to get the average speed, we know the formula for average speed is total distance covered divided by total time taken. So total distance covered is 9 kilometer and the total time taken for this journey is 1 hour. So dividing 9 by 1, we will get the average speed, that is 9 kilometer per hour. Now for displacement from the starting point. So as you can see that first the boy moved 5 kilometer due west and then returned back travel further a distance of 4 kilometer. In this way, the resultant displacement by the boy is first 5 kilometer due. Let's suppose if the boy has moved a distance of 5 kilometer due west, so you will have to move towards your left, and you can represent this displacement of 5 kilometer due west in this way, that is towards left side. Considering the frame of reference direction, you can see that on the right side we have east, on the left we have west, on the top it's north, and at the bottom we have south. So considering the question that's given to us here, 5 kilometer due west and then return back. So 5 kilometer due west and then return back 4 kilometer. So this is the starting point O. From O to A, this is 5 kilometer due west, and then he returned from this point towards the starting point 4 kilometer, let's suppose up till this. So if this distance on his return journey, this track is of 4 kilometer, then obviously this his new current position, that is representing his displacement from the starting point, and you can mark it as B. So the net displacement from the starting of the journey till the end of the journey is OB, and obviously this is 1 kilometer. And because his position, current position or the final position is in the west, so the displacement of the boy's journey is 1 kilometer. His displacement is 1 kilometer towards west. So this is the way how we solve particularly the displacement question. For finding the distance, it's very simple, like ABC. Just what we have to do for finding the total distance, simply adding the values given to us for the distance covered. But for displacement, we have to consider the direction in which the body is traveling for the first interval of time and then for the second interval of time. And then we can find the displacement from the initial position from where he has started his journey till the end point of the journey. So that we have to find by the figure like this for better understanding. And then if it is a right angle triangle case, then the displacement is always obtained by using the Pythagoras theorem, that is hypotenuse square is equals to base square plus perpendicular square. So substituting the values for base and perpendicular, then taking their squares, and then the squares are added together, and then finally the sum give us the value for hypotenuse square, but we are in need of hypotenuse, not the square of hypotenuse. For finding the hypotenuse, we have to remove the square from hypotenuse. So if we remove the square above hypotenuse, then its value will come under radical sign, because we know the algebraic rule, like if you have x square is equals to 100 and you want to find the value of x, for that what you have to do, you have to remove this square from x. Then if you remove the square from x, then its value, which is given to us for x square is 100, this will come under radical sign. And the square root of 100 gives us 10. So in this way, the value for this x, which we are considering here or denoting the symbol for displacement, is 10 kilometer. Now if we are going to find the average velocity, so because average velocity formula is total displacement over total time taken, formula for average velocity that we have also discussed in the previous example is total displacement covered divided by total time taken. In this part, the total displacement is 1 kilometer and the total time of the journey is 1 hour. So the average velocity is 1 kilometer per hour. This is the average velocity. So how do we get the average velocity? By dividing the total displacement covered by total time taken. Average velocity formula is total displacement covered divided by the total time of the journey. That will give you the average speed. So here the average speed we got as 1 kilometer per hour. Now you can see this example. In this example, a car travels along a route PQRST in 30 minutes. So the car covers the distance in 4 segments of time interval. In the first, from P to Q covered 10 km, then from Q to R 5 km, and then from R to S 10 km, and finally from S to T 5 km more. Then the question is, what is his average speed? Find the average speed of the car. For this, simply we will add all the distance covered, that is adding 10 plus 5 plus 10 plus 5. That will give us 30 km. So the total distance covered by the car in this journey is 30 km, and the total time elapsed for this journey is 30 minutes. And you can see here the options given to us are all in kilometer per hour. So what we have to do to find the right option? For this, first of all, we will convert the time taken from minutes to hour, because the options, in all the options given below, the average speed is given in kilometer per hour. So we must have to change the time from minutes to hour. And how do we change the time from minutes to hour? We simply divide it by 60, because we know that in 1 hour there are 60 minutes, and as we are converting a smaller unit, that is minute to hour, smaller to bigger, for that we have to divide it by 60 by the relation between the two time units. So we know that 1 hour is equals to 60 minutes. If we are converting hours to minute, we have to multiply it by 60. That is a bigger unit to a smaller one. So if we are converting time from hours to minute, we have to multiply it by 60. But if we are converting the time from minutes to hour, that is a smaller unit is converting into a bigger unit, for that we have to divide. That's why we have divided 30 by 60, and it gives us 0.5 hour. So the time taken is 0.5 hour, and the total distance covered is 30. So 30 divided by 0.5 will give you 60 km per hour. So the average speed of the car is 60 km per hour. Dividing the total distance covered, which is 30 km, adding all these four values, give us 30 km. So the total distance covered is 30 km, and the total time elapsed, the total time taken for the journey is 30 minutes. Converting 30 minutes to hour by dividing it by 60, we got the time in hour, which is 0.5 hour. So dividing the total distance covered 30 kilometer by the time taken in hours, 0.5 hours, we got the average speed as 60 kilometer per hour. Then a man crosses a road 8 meter wide at a speed of 2 meter per second. The question is, how long does the man take to cross the road? So whenever in the question it is asked from you, how long does this take place, or for how long will it take to do this thing, it means that simply they are asking the time value. Here in this question we are given the distance of the road that is has to be covered is 8 meter wide road, and the speed with which the man is crossing the road is 2 meter per second. So using the formula of speed, that is total distance over, or distance covered divided by time taken. Speed formula is distance covered divided by time taken. So for this, if you are going to find the time taken, you are using the formula for speed, that is distance covered over time taken. Distance covered over time taken, and we are given here the total distance covered as 8 meter, and along with this distance covered of 8 meter, we are given the speed of the man as 2 meter per second. The speed of the man is given as 2 meter per second. This is 2 meter per second, and the distance covered is 8 meter. The distance covered is 8 meter. So dividing, substituting the value for distance is 8 meter. What we have to find here? We have to find here the time. In this numerical, we are given the distance covered by the man as 8 meter. The man is crossing the road whose distance is, or the width of the road is 8 meter, and he is traveling at a speed of 2 meter per second. The question is, how long does it take for the man to cross the road? For this you have to make the subject of the formula time t, and for this you will shift this time from denominator of the fraction to the left side. So when it is multiplied by time, and now we got 2t is equals to 8. For finding or driving it for the time taken t, we have to shift now this 2 towards right side, and it will come at denominator. In this way the time taken for this is 4 seconds. So if the man is traveling at a speed of 2 meter per second and he has to cross the road of 8 meter, then simply the time taken by him will be 4 seconds. So it was another simple question. I hope you can easily understand this. Okay, now moving for the next question. So the right option is A, that is 4 seconds. Okay, then a child is standing on the platform of a station watching the trains, a train traveling at 30 meter per second. So again in this numerical, we are given the speed of the train 30 meter per second, and the train took 3 seconds to pass the child. And you have to find the length of the train. So whatever be the length of the train, actually the train has covered this distance, which is equal to the length of the train, by passing it through the child. So the total distance, that is the length of the train, is required, and we are given the speed 30 meter per second, and the time taken by the train to pass through the child is 3 seconds. So the time taken is 3 seconds, and the speed is 30 meter per second. The speed is 30 meter per second. Then what you have to do, speed is given to us 30 meter per second, and time taken is 3 seconds. So again, using the formula of a speed, that is distance covered divided by time taken, distance covered divided by time taken. So in this question we have the we are given the speed of the car, that is, you can see from the question, speed of the car is 30 meter per second, and the time taken by the train to pass through the child is 3 seconds. So time is 3 seconds and the speed is 30 meter per second. This is 30 and the time is 3 seconds. You have to find the length of the train, that is actually the distance traveled for this duration by the train, which is exactly equal to its length of the train. So this distance covered is actually giving us the length of the train. Now to find this distance covered by the train, that is giving us the length of the train, we have to shift this 3, the time in 3 seconds, towards the left side of the equation. So when you multiply this 30 by 3, you will get the distance traveled by the train in this 3-second duration of time. So the distance covered by the train is actually here same as the length of the train, that is 90 meter. So this is giving you the length of the train, which is 90 meter. Length of the train 90 meter. Okay, then so the right option is C, 90 meter. Okay, then in the same way, for example, a car driver takes a total of 2 hours time to make a journey of 75 kilometer. So the total distance that the driver has to cover is of 75 kilometer. Before driving, she took first a coffee at the coffee shop, and that spends nearly half an hour. So from the total time of 2 hours, half an hour is consumed or half an hour is used up, and now the remaining time is 1.5 hours. After this, when she started to drive, she was stuck in a traffic jam for quarter of an hour. It means that the total time that is wasted in a sense is half an hour and then quarter of an hour. So that makes actually 3/4 of the hour. So what was the total time for the journey that was given to her is 2 hours. She has to cover this distance of 75 kilometer journey in 2 hours, and out of these 2 hours she has already used up a time of 3/4 of the hour, that is 3/4 of the hour. Now the remaining time left is 1.25 hour. 1.25 hour, and she has to cover the same distance of 75 kilometer. For solving this, we are given here, we have to find at what speed does she has to move or drive the car. For this, we are using again the formula of speed, that is speed is equals to distance covered divided by time taken. Now the distance covered is same, which is 75 kilometer, and the time left for her is 1.25 hour. 1.25 hour means 1 hour and 15 minutes, and in hour you can say 1.25 hour, or you can also write in common fraction as 1.25 hour. So 1.25 hour means 1.25 hour, or 1 whole 1 upon 4 hour. And when you want to change this in improper fraction from this mixed to improper, that will make it as 4 ones are 4 and adding 1, this is 5 over 4 hour. So you may also write in an improper fraction as 5 over 4 hour. So the time remaining for covering the same distance of 75 kilometer, the time remaining for her is 1.25 hour, that is 5 upon 4 hour, or in decimal you may substitute it as 1.25 hour. So it's your wish which one you like the easier, you can substitute it. Okay, so if I say 5 over 4, so I just wrote here 5 over 4. Now we know that when it is 75 divided by 5 over 4, in the next step, whenever we change the division sign to multiplication, we have to reciprocate the fraction. That is, writing its reciprocal or its multiplicative inverse. So that is 4 over 5. Now, dividing 75 by 5, we get 15. And 15 multiplied by 4 is 60 kilometer per hour. So this is actually this 60 kilometer 60 kilometer per hour, 60 kilometer per hour is the speed of the car at which she has to drive to cover the same distance of 75 kilometer journey. So here the C option is the right option, which is 60 kilometer per hour. So this was another example of finding the average speed. Okay, then we are given another simple question. A car takes 1 hour to travel 100 kilometer along a main road, and then half an hour to travel another 20 kilometer along the side road. So first the car has to cover a distance of 100 kilometer, and it takes 1 hour for the car for it to cover 100 kilometer. And then for the next step, a 20 kilometer distance along the roadside was covered in half an hour. And the question is find the average speed. So it's very simple. To find the average speed, we will add the distance covered, that is 100 kilometer plus 20 kilometer. That gives you 120 kilometer. Now dividing the total distance covered by the total time taken. So the first 100 kilometer distance is covered in 1 hour, and the second 20 kilometer distance is covered in half an hour. So adding 1 with half, you will get 1.5, and 1.5 in other sense gives you 3 over 2. So the total time taken is 3 over 2 hours, that is 1.5 hours. You can also write it in decimal fraction as 1.5. So the total time taken is 1.5 hours and the total distance covered is 100 plus 20, that is 120. Now you will simply divide this total distance of 120 kilometer by the total time taken to get the average speed. Total distance covered, as I told, is the sum of 120, that is 120 kilometer, and then dividing this total distance by the total time taken, which is 1 hour and half an hour. So adding 1 and a half, you will get 1.5 hour, and in common fraction you may write it as 3 upon 2 hours. So both will give you the same answer. Now dividing 120 by 1.5, so it will give you, if I replace the decimal, remove the decimal, I just have to add 10 to the numerator. Now it's 1200 over 15. So dividing this by 1200 by 15, we will get 80 kilometer per hour. So this is the average speed of the car. Average speed is denoted by a bar placed over V. Simply V represents the speed, but when we place a bar over V, that stands for average speed. Then in the next part, we are given here some distance covered by a car and the time taken by it for the 4 different stages from P to S, from P to Q, then from Q to R, and then from R to S. So for all these stages, we are given here the time interval and the distance traveled. So for the stage P, the distance covered or the distance traveled is 1.8 and the time taken is 2. So the average speed at point P is 0.9 kilometer per hour. At the stage P, at the stage P, the average speed is 0.9 kilometer per hour. Now for the stage Q, the total distance traveled is 3.6 and the total time taken in minutes are 2 minutes. Dividing 3.6 by 2, you will get 1.8 kilometer per hour. Then for the stage R, it's 2.7 the total distance traveled and the total time taken is 4 minutes. Dividing 2.7 by 4, your answer will be 0.6 and then 25 kilometer per minute. Then for the stage S, total distance 2.7 divided by 3 is 0.9 kilometer per hour. So you can see that at stage P, we got the speed as 1.8 divided by the time taken in minutes. At stage P, the speed at stage P is 0.9 kilometer per minute. And at stage S, at stage P, the average speed is this, and then at stage S, the average speed will be 2.7 divided by 3. So that also give us the same interval for the same average speed of 0.9 kilometer per hour. 0.9 kilometer per hour. So the right option is at stage B, and at stage S the average speed of the car is same. So during which two stages is the car traveling at the same speed? What was the question actually? During which two stages, as I already told you before solving the question, that they are asking in this question that what are the two stages where the body have the same speed. So it was at stage B and S. So which option is the right option here? Option B. Okay. In this question, the circuit of a motor racing track is 3 km in length. In a race, a car goes 25 times round the circuit in 30 minutes. What you have to find here? You have to find here the average speed of the car. To find the average speed of the car, simply we will again use here the formula for average speed, that is total distance traveled over total time taken. So average speed is total distance covered or total distance traveled over total time taken. Total distance covered over total time taken. You can see here that the total distance is actually when the motor car is covering the racing track, which is of 3 km. So a single track is of 3 km, and the racing car has completed 25 times round the circuit. It means that the distance of 3 km, which is for one complete track, is covered 25 times. So the total distance covered will be 3 multiplied by 25, that is 75 km. And the time taken for this is 30 minutes. But you can see the given options. In all the four given options, the speed is given in kilometer per hour. It means that the time must be in hour, but we are given the time in minutes. So what we will do, we will divide this 30 minutes by 60 to convert it into hours. So it will be 0.5 hour. Now dividing this by 0.5, so it's 75 over 0.5. Dividing 75 by 0.5 will give you 150 km per hour. So this